Welcome to the deep dive. Today we're setting our sights on Starlink. That's the satellite network being built out by SpaceX.
Right. Big topic.
Yeah, exactly. We've gathered a bunch of articles, expert opinions, trying to really dig into this whole thing. Our goal, basically, understand the facts, this push for low-cost internet in remote spots.
But also the concerns. And there are definitely concerns.
Oh, yeah. Especially for astronomy, the environment. We'll get into all that.
So Starlink's main idea really is getting past the limits of like cables in the ground, internet for everyone, everywhere.
And the scale is just, it's kind of staggering when you think about it. SpaceX is talking about a mega constellation.
That's the term, yeah.
Yeah.
A huge web of satellites. They're hoping for maybe up to 42,000 eventually.
42,000. And the new ones, the V2s, they're heavy, like 1,760 pounds each.
About 800 kilograms, yeah.
Yeah.
Much heavier than the first generation, which were around 570 pounds or 260 kilos.
So nearly triple the weight. That's going to change things in orbit, density-wise.
Absolutely. And it's already a pretty big presence up there. As of, late March 2025, Jonathan McDowell, he tracks this stuff.
Yeah, he's the go-to guy.
He counted 7,135 Starlinks in orbit. And most of them, 7,105, are operational.
Okay, so with that many satellites going up so fast, naturally, questions arise. Big ones.
Like what it does to astronomy, right? Looking up with telescopes or listening for radio waves.
Uh-huh. And just the traffic up there, the risk of collisions.
And even what happens when they, come down, burn up in the atmosphere, could that change things?
Potential climate effects, yeah. Okay, let's dive in. Maybe start with something you might actually see yourself.
Right. So these things orbit about 342 miles up, 550 kilometers.
Relatively low then.
Yeah, low Earth orbit. And because they catch the sunlight, you can sometimes see them from the ground. They look like a string of pearls or a sort of train of bright lights moving across the sky.
A string of pearls, I've heard that. Sounds kind of cool, but maybe a bit worrying for astronomers.
Exactly. It's beautiful, maybe,
Yeah.
but it's also fundamentally changing the night sky, which is, for everyone.
And apparently, they're easiest to spot just after a launch, like a day or two after.
Yeah, before they spread out and climb to their final orbit, they get fainter then.
Space.com actually recommends using stargazing apps. Or there are specific Starlink maps online if you want to try and track them in real time.
So, yeah, you might be able to spot them. But the why behind this huge network is important too.
Right, the purpose.
It's about reaching areas where internet is, shaky or just doesn't exist. Bridging that digital divide.
Which is crucial for things like education, telehealth.
Absolutely. And even for emergency communications. Think natural disasters, getting comms back up quickly.
Starlink actually has an interactive map on their website, doesn't it? Showing where it's available, where there's a wait list.
Yeah, and where it's coming soon. Really shows the global scale they're aiming for.
Okay, so let's rewind a bit. How did this whole ambitious project even get started?
Well, Elon Musk announced the idea publicly back in January 2015.
2015, okay.
Initially, the plan was for about 4,000 satellites. Still a lot, but,
Less than 42,000.
considerably less. He talked about it as like rebuilding the internet in space.
Rebuilding the internet in space. Wow. And that 4,000 number didn't last long, did it?
No. The US FCC, they granted permission for 12,000.
12,000.
And then paperwork got filed for potentially another 30,000 on top of that.
It's just, the numbers are hard to comprehend, especially when you compare it to, like, all satellites ever launched before this.
Right. Someone crunched the numbers. As of late 2022, in all of history, humanity had launched maybe 14,500 satellites total.
And only about, 6,800 were still active then?
Exactly. So Starlink's plan for tens of thousands. It really puts it in perspective. It's a massive undertaking.
When did they actually start launching?
The first test ones went up in February 2018. They called them Tintina and Tintin-B.
Okay.
Then the first batch of 60 operational satellites launched in May 2019.
And that's when people really started noticing. The astronomers.
Oh, yeah. Almost immediately after that first big launch, observers started reporting these really bright trains of lights. Brighter than expected.
Brighter than expected. So were astronomers consulted beforehand, Or was the brightness a complete surprise?
SpaceX did talk to some astronomers, but yeah, the actual observed brightness seems to have caught many off guard.
And that's where the problem started, seeing streaks in their data.
Exactly. Streaks of light cutting across images. And the worry is what this does to really sensitive work, like the Vera Rubin Observatory.
Which is supposed to survey basically the whole sky, right? Coming online soon.
Yeah, studying the entire universe in incredible detail. These streaks could really compromise that kind of work.
And it's not just optical, looking with eyes or cameras. Radio astronomy has concerns too.
Big concerns, because Starlink satellites use radio signals to beam internet down. Lots of signals.
And that interferes with the faint radio waves astronomers are trying to listen to from space.
That's the fear. Even if Starlink sticks to its assigned frequencies, the sheer power and number of transmitters could cause spillover, creating noise that drowns out faint cosmic signals.
So the International Astronomical Union, the IAU, they weighed in pretty early.
They did put out a statement in 2019 expressing concern, urging, cooperation to figure out the impact.
And the American Astronomical Society, the AAS.
They went a step further, basically comparing it to light pollution,
Yeah.
saying these constellations could significantly brighten the night sky for everyone.
So losing the darkness of the natural night sky, that's a profound thought.
It is. We looked at comments from Meredith Rawls, a stellar astronomer.
Okay, what's her take?
She points to two main issues. Just the sheer number of satellites and their brightness, how much sunlight they reflect.
That brightness was the initial shock, wasn't it?
It really was. And she thinks the impact on radio astronomy might actually be even worse.
Worse than the optical streaks. Why?
Because they're constantly beaming signals down for the internet service. It's not intermittent. And even with rules about frequencies.
There could be leakage, interference.
Potentially for spillover, yeah. A constant background noise from thousands of sources moving across the sky. It's a different kind of challenge than, say, one radio tower on the ground.
That makes sense. Now, she also had an interesting point about the orbits, didn't she? Lower versus higher?
Yeah, kind of counterintuitive. You'd think higher up would be better for optical astronomers further away, fainter.
Right.
But she actually said lower orbits are preferred.
Why is that?
Because even though they might look brighter momentarily, they move across the sky faster. So in a long exposure image, the streak they leave is actually fainter.
Huh. Faster movement, fainter streak. Interesting.
Yeah. She mentioned being disappointed that another company, OneWeb, chose higher orbits for their constellation.
But lower orbits bring their own issues, right? Like crowding.
Exactly. Which leads us straight into the next big concern, collision risk.
Right. We had that near miss back in September 2019, the ESA's Aeolus satellite.
Yeah, I had to actively maneuver to avoid hitting Starlink 44, one of the early satellites. That was a real wake-up call.
So are there, traffic rules up there now? International agreements for avoiding crashes?
It's complicated.
Yeah.
Right now, it's mostly down to the operators themselves coordinating, sharing data, and moving if needed. But it's getting much harder.
Because of Starlink?
Largely, yes. Hugh Lewis, he's an expert in space debris. Back in August 2021, he was already saying Starlink was the main driver of collision risk in low Earth orbit.
The main driver? Wow.
His models were showing something like 1,600 close encounters within a kilometer, so about half a mile involving Starlink satellites every week.
Every week?
Yeah, and that was apparently about half of all close encounters between any two spacecraft at the time.
And that number's only going up as they launch more.
Expected to rise dramatically. Could reach 90% of all encounters once the first 12,000 Starlinks are up. Low Earth orbit is becoming a congested space.
Which really raises questions about one company, SpaceX, having such a dominant role, and how its choices affect everyone else operating up there.
Absolutely. Safety for all operations is a concern.
Okay, so these satellites, they don't last forever. What's the end-of-life plan?
SpaceX says they plan to refresh the constellation roughly every 5 years.
Refresh, meaning?
Meaning the older satellites get deliberately deorbited. They're steered back into the atmosphere.
Or they burn up.
Right. Which avoids leaving dead satellites floating around as space junk long term.
But It creates a different potential problem, doesn't it?
It does, a potential environmental one.
Because of what they're made of, burning up all that material.
Exactly. They're largely made of aluminum.
Mhm.
And the concern raised by researchers like Aaron Boley in Canada is about what happens when thousands of tons of aluminum burn up high in the atmosphere.
What are the worries there?
The main product is aluminum oxide, alumina. Boley suggests this could potentially deplete ozone and maybe even change the Earth's albedo, how much sunlight it reflects back into space. Essentially, unintended geoengineering.
Wow. So trying to connect the world might inadvertently affect the climate.
It's a possibility that needs serious study. Experts at NOAA, the U.S. Atmospheric Agency, have also voiced concerns about the long-term buildup of these particles way up high.
How does the amount compare to, say, natural stuff burning up, like meteors?
Well, Boley noted that initially, the daily mass of deorbiting Starlinks might be less than the mass of meteoroids hitting the atmosphere, maybe 2 tons versus 60 tons daily.
Okay, so less mass overall.
Less mass, yes, but the key difference is the composition. Meteors are mostly rock. Starlinks are mostly aluminum. We just don't know the long-term effect of adding all that specific material, the alumina, to the upper atmosphere.
It hasn't happened before on this scale.
Nope. Boley drew a parallel to how we maybe didn't grasp the impact of plastics in the ocean or CO2 in the air early on. A cautionary tale about underestimating our impact.
Yeah, makes you think. And their lifespan isn't always guaranteed to be 5 years either, right? Didn't they lose a batch recently?
We did. February 2022, a geomagnetic storm, basically a solar storm hitting Earth, increased the atmospheric drag just enough.
Drag. Even that high up?
Yeah, there's still a tiny bit of atmosphere. The storm made it denser temporarily, and it dragged down up to 40 newly launched Starlinks, causing them to deorbit prematurely.
So even nature can interfere. Now, SpaceX isn't standing still. They're upgrading the satellites, aren't they?
Right. They started launching these V2 mini versions in early 2023.
V2 minis, like a smaller version of the next generation.
Kind of a precursor. The full V2 is designed for their bigger Starship rocket, which isn't fully operational yet, but even these minis are a step up.
How so?
They're bigger, more capable than the first generation, better thrusters, new antennas, more data capacity,
The full V2s when they come.
even more capacity.
Yeah.
And they're planning direct-to-cellular service. Remember, they announced a partnership with T-Mobile?
Oh, right. So your phone could connect directly to a satellite.
That's the idea.
Yeah.
Shows they're thinking beyond just the dish-on-your-roof model. But, Starlink's also proven really valuable in some tough situations.
Yeah, the emergency response aspect, you mentioned that earlier.
Because you can deploy it fast, in remote spots, it's been a game changer for emergency responders. SpaceX says they prioritize service for them.
And we saw that play out very publicly in Ukraine.
Absolutely. It became vital communication infrastructure there after the Russian invasion. Thousands of terminals were sent over.
And Tonga too, right? After the volcano and tsunami.
Yeah, they provided free internet access there when other communications were down. Really shows a positive potential.
Though there were challenges like signal jamming attempts in Ukraine.
True. It's not always smooth sailing. Now, what's SpaceX doing about all these concerns we've discussed? The astronomy impact, collisions.
Well, they say they're committed to working with groups, space agencies to mitigate things.
Okay. Like what?
Patricia Cooper, a VP at SpaceX, she told astronomers back in 2020 they were serious about finding a way forward.
Any concrete actions?
They did deploy those visors on newer satellites, little shades basically to try and block sunlight reflection and make them less bright. And did that work? Are the visors effective?
They seem to have helped reduce the brightness somewhat. But many astronomers say it's not a complete fix, especially with the sheer number of satellites planned. And effectiveness can depend on the angle.
So still an ongoing issue.
Very much so. And despite SpaceX's efforts, you've got other companies planning constellations too. So the overall light pollution, the collision risk, these broader issues aren't going away.
Which leads to more calls for like actual government regulation, not just relying on companies to self-regulate.
Exactly. There's a growing feeling that maybe stronger rules are needed for managing these huge constellations.
Okay, so let's shift gears slightly. For someone on the ground, how does this actually work? Getting internet from these satellites, they're different from the old TV satellites, right?
Totally different. Those big geostationary satellites are way, way further out. Starlink is much closer.
Which is key for speed, isn't it?
It's key for latency, the lag time. Because they're only about 342 miles up, the signal travel time is much shorter.
Compared to over 22,000 miles for geostationary.
Right. That huge distance creates noticeable delay, which is bad for video calls, online gaming, things like that. Starlink's low orbit avoids most of that lag.
And the satellites themselves, you said they're like table size?
Roughly, yeah. The current main version weighs about 573 pounds, 260 kilos, and they beam the internet data through space using radio waves. Faster than fiber optic cables, actually, because light travels faster in a vacuum than in glass.
Huh. Didn't know that. So if I wanted to sign up, what do I need?
You need the Starlink kit. SpaceX sells it. It comes with a satellite dish.
The Dishy McFlatface.
That's the nickname, yeah. It's got a motor to aim itself. Then there's a Wi-Fi router, cables, power supply, the usual stuff.
You order it online?
Yep, through the Starlink website. You put in your address, tells you if service is available, or if you're on the wait list.
Pricing varies, I assume.
It does. Depends on your region, the plan you choose. The example we had was from Brooklyn back in late 2022. It was around $600 for the hardware kit.
Oof. Pricey startup.
Yeah, plus maybe $50 shipping and about $110 a month for the service itself.
And the speeds they promise.
Advertised between 100 and 200 megabits per second download with that low latency, like 20 milliseconds in most places.
Which is pretty good, especially if your alternative is nothing or slow DSL.
Exactly. And the installation is apparently pretty user-friendly. There's an app to guide you, helps you find the best spot for the dish with a clear view of the sky.
Okay, so wrapping up this deep dive then, Starlink. It's clearly this massive, ambitious project.
Huge potential, definitely. Connecting underserved areas, helping in emergencies. Those are real benefits.
But as we've spent a lot of time discussing, it comes with some really significant baggage. Serious concerns.
The impact on how we see and study the universe, optical and radio astronomy, the growing danger of collisions turning low Earth orbit into a minefield.
And these potential kind of scary long-term environmental effects from burning up thousands of satellites in the atmosphere, things we don't fully understand yet.
It really throws that tension into sharp relief, doesn't it? The drive for technological progress versus the potential consequences for, well, our planet and our view of the cosmos.
Yeah, it's a classic dilemma, scaled up massively. Which brings us to a final thought for you, the listener. As we see this explosion of space-based tech, not just Starlink, but others too, what are the responsibilities here, particularly for private companies driving so much of this? How should we manage these shared resources, space itself, and Earth's atmosphere?
It's a huge question, one that's only going to get more pressing as we push further out.
Definitely something to think about. Thanks for joining us for this deep dive.